Okay. So we're just talking about these things. So let's say we take this one, and it's normalized properly. So this, right, with this C, that would normalize it. So generating function for this thing, just stick it in, right? You take your piece of K, whatever it is, the blob, and you stick it in, and sum away. And often, if you've got powers like this, or yeah, so this blob can be connected to the X, right? So what did I do there? I guess I could show you that. So nice. Ooh, is that bad? Oh, no. Okay. Yeah, it's not bad. The rubber. Yeah, so this problem was, right, we have, I don't want to label the point too much, but it's all right. Okay, so we've got this thing, we'll pull the C out, and we've got e to the minus lambda k, x to the k, so this is C, and then e to the minus lambda x to the power of k equals 0 to infinity. Good? Yep. And so this is just a geometric sum, right? This is blob to the power of k. Oh yeah, I really would be. Thank you, very kind. You're very kind. Magic rectangle. Thank you. Okay, so I'm just writing down what was there and then just grouping the things, right? This is a constant at the front, blob to the k. It's just a geometric sum. So there are tons of these sorts of things in what we're going to do. And so that's always, it's 1 over 1 minus blob in this case. It starts from, you have to be careful about this. It starts from k equals 0. You think of this as our r, and so this is e to the minus lambda x. And there was a c. Okay, so lots of those. So they're not super high power, but you have to be careful with these things and right. Okay, good. So some small good pieces here. So if we set x equal to 1, we'll think about what happens here, right? X equals 1, it's the sum from k equals 0 to infinity of piece of k, which is, it has to be 1, right? It's a probability distribution, so it has to be 1. So it's always going to happen unless for some reason we have a distribution that's summing to, right? The probability of things happening is less than 1. But we'll see that's a possibility later. Okay, so we should be able to stick that in here. So if we put a 1 here, 1 minus e to the minus lambda, the normalization is 1 minus e to the minus lambda. So this is good. It's a small piece. All right, so that's always true. Okay? And you can see that for the other ones, right? We had a half 1 plus x. So we put x equals 1 in there. We get a half times 2. And we had a 6, and it was 1 plus 1 plus 1 plus 1, right? So we'll get 1 again. Okay.